Welcome to ELN 260, Cyber Safety Lesson 3, Secure Programming and Documentation Practices. In this lesson, we will focus on how cyber-safe habits can be applied directly to PLC projects. As industrial systems become more connected and more complex, it is not enough for a program to simply work. It must also be protected, backed up, organized, and documented clearly. These practices help reduce the risk of unauthorized changes, data loss, and confusion during troubleshooting or recovery. As we move through the lesson, think about how these habits apply to the PLC work you do in class and in real industrial environments. Now, let's begin by thinking about what could happen without these protections in place. Imagine a PLC program that controls an important industrial process. Now imagine that the program is changed, deleted, or overwritten, and there is no password protection, no backup copy, and no documentation explaining how it works. In that situation, operations could be disrupted, safety could be affected, and recovery could become very difficult. This example shows why secure programming and good documentation are not optional. They are essential practices for protecting industrial control systems. Now, let's look at the main objective of this lesson. This lesson explains how cyber-safe habits can be applied to PLC projects through password protection, secure backups, and proper documentation. These practices support reliable programming, organized use of memory, and safer industrial control design. As we move through the lesson, keep in mind that secure programming is not separate from good engineering practice. It is part of how we build systems that are reliable, maintainable, and safer to operate. Let's begin by looking at the kinds of threats these practices help reduce. Secure programming and documentation practices help protect PLC systems from accidental errors, unauthorized changes, and cyber incidents. In industrial settings, good cybersecurity is not only about networks and devices, it also includes how programs are written, protected, backed up, and documented. This broader view is important because many problems in industrial control systems stem from weak practices rather than from advanced attacks. That leads us to the next question. Why does secure programming matter so much? PLC programs control real industrial processes. If a program is changed without approval, poorly documented, or lost because of a system problem, the results can affect safety, production, and equipment performance. Secure programming habits help reduce these risks by keeping projects more controlled, more understandable, and easier to recover. In industrial environments, secure programming helps protect both the process and the people who depend on it. Cybersecurity in PLC projects goes beyond just blocking outside threats. Cybersecurity in PLC work includes more than stopping hackers. It also means protecting projects from unauthorized edits, accidental overwrites, missing backups, and poor documentation. A secure project is easier to maintain, troubleshoot, and recover. This is an important point because strong cybersecurity often begins with simple daily habits that improve both security and overall project quality. One of the most basic protections we use is password protection. Password protection helps prevent unauthorized users from viewing, editing, or downloading PLC programs. It can be used to limit access to programming software, controller settings, and project files. This helps protect both the logic and the control system. In PLC environments, controlling access is one of the first steps in protecting the integrity of the program. So why are passwords so important in this kind of work? Without password protection, anyone with access to the programming device or software may be able to change the PLC program. Unauthorized changes can alter timing, outputs, alarms, or machine behavior. Strong password practices help reduce that risk. In industrial systems, a small unauthorized change can have much larger consequences, so access control matters. Good passwords are only helpful if they are managed correctly. Good password practices include using strong passwords, limiting who knows them, avoiding shared logins, and changing passwords when needed. Access should be based on job role, so only authorized personnel can make program changes. These habits improve accountability and reduce the chance of unauthorized or careless edits to important PLC projects. Another important protection is keeping secure backups. A secure backup is a protected copy of the PLC program, configuration, and related files that can be restored if needed. Backups help recover from accidental deletion, hardware failure, corruption, or unauthorized changes. In industrial settings, backups are a key part of recovery planning because they make it possible to restore known good logic and return systems to service more quickly. That is why backups matter so much in PLC work. If the only copy of a PLC project is stored on one computer or one controller, the project can be lost. Keeping secure backups allows technicians and engineers to restore known good logic and reduce downtime after an incident. Backups help turn a major disruption into a recoverable problem. Now let's talk about why backups matter. If the only copy of a PLC project is stored on one computer or one controller, that project can be lost if something goes wrong. A hardware failure, an accidental overwrite, or another problem could make recovery much harder. Secure backups allow technicians and engineers to restore known good logic and reduce downtime after an incident. In other words, backups help the team recover faster and more safely. That is why backups are such an important part of PLC cybersecurity. They protect the project, support troubleshooting, and help keep operations moving when problems occur. To be effective, backups need to be done the right way. Backup best practices include saving multiple versions, storing copies in secure locations, labeling files clearly, and backing up after approved changes. A good backup should make it easy to identify the correct version of the project. Clear organization matters because during recovery, teams need to know exactly which version is trusted and current. Backups are only part of the picture. Proper documentation matters too. Proper documentation explains how a PLC program works and how the control system is designed. Good documentation may include tag names, rung descriptions, comments, I/O lists, network information, revision history, and change records. This information makes projects easier to understand, maintain, and troubleshoot. It also helps teams work more confidently and consistently. Documentation also supports security in an important way. Documentation supports cybersecurity because it helps authorized users understand the program and detect unexpected changes. When projects are clearly documented, it becomes easier to troubleshoot problems, verify logic, and recover from incidents. Good documentation also improves accountability because it shows what changed, when it changed, and why. In industrial systems, clear documentation supports both reliability and security. Secure programming also includes how memory is organized. PLC memory organization is also part of secure design. Clear use of tags, addresses, file structure, and data storage helps prevent confusion and programming mistakes. Organized memory makes projects easier to review, troubleshoot, and protect. When projects are structured clearly, they are less likely to be misunderstood or changed incorrectly. That connects directly to the larger idea of secure design. Industrial control design should include planning for who can access the system, how changes are approved, where backups are stored, and how documentation is updated. Security should be part of the design process, not something added only after problems occur. This kind of planning helps create systems that are easier to manage and more resilient over time. Let's look at a real-world example that shows why secure programming and documentation matter in industrial control systems. In the Triton incident, attackers targeted Schneider Electric Triconex safety controllers at a petrochemical facility. These controllers are part of the safety system that helps move equipment into a safe shutdown state when dangerous conditions occur. This example is important because it shows that cybersecurity is not only about protecting networks, it also involves protecting the controller logic, controlling who can make program changes, and keeping accurate records of what was changed and when. If a system is changed and there is no clear documentation, no approved version, and no known good backup, recovery becomes much harder. Engineers and technicians may not know what the original logic was, what was modified, or how to safely restore the system. That is why secure programming and documentation practices are so important. Good change control, Secure backups, version tracking, and clear documentation help teams detect unauthorized changes, recover more quickly, and maintain safe operation. The main lesson is that secure programming protects more than code. It helps protect people, equipment, and the reliability of the entire control system. So, how can students apply these ideas in their own work? Students can apply cyber safe habits by protecting project files, using secure passwords, backing up work regularly, documenting logic clearly, and recording changes carefully. These habits improve both cybersecurity and overall project quality. They also help build the kind of professional discipline that matters in real industrial environments. That brings us to the key takeaway from this lesson. Secure PLC programming includes more than writing code that works. It also requires protecting access, maintaining secure backups, organizing memory carefully, and documenting the project clearly. These practices help create safer and more reliable industrial control systems. Good cyber safety habits support good engineering. Now let's wrap up the lesson. You have now completed Lesson 3 on secure programming and documentation practices. In this lesson, you learned how password protection, secure backups, proper documentation, organized memory, and secure design practices help protect PLC projects. These habits support safer, more reliable, and more maintainable industrial control systems. As you continue through the course, remember that secure programming is part of professional PLC work, not an extra step added at the end. Thank you for completing this lesson. As you move forward, keep these cyber-safe habits in mind each time you create, edit, backup, and document a PLC project. Strong technical work and strong security practices go hand in hand.